video, we are going to solve the problem number 1.73 from Irodov, and that is related to dynamics. So let us first understand the problem and then we will solve the problem step by step. So we are having this arrangement shown in this particular figure where the bodies are having masses m0, m1 and m2, and it is said that the friction is absent. The masses of pulleys and the threads are negligible, and we have to obtain the acceleration of body mass m1. Okay, so what we can do first, let us say this particular mass m0 is moving with acceleration a0. So as the pulley is connected with the same thread, so the acceleration of pulley will also be the acceleration of a0. And let's say with respect to pulley, the mass m2 is having the acceleration of w. As both the masses m1 and m2 are connected with the same thread, then the mass m1 will also have the same acceleration of w, that is with respect to pulley. Okay, and if we talk about the net acceleration of mass m1, so let us say acceleration of mass m1, that would be a0 minus w. As with respect to pulley, the mass m2, let's say it is going in the downward direction with the acceleration of w, so mass m1 will go in the upward direction with the acceleration of w. And as the pulley is moving with the acceleration of a0, so that's why we will have the net acceleration of m1, that is a0 minus w, because both the acceleration are in the opposite direction. While if we talk about the acceleration of mass m2, then acceleration of mass m2 would be a0 plus w. Okay, so let us first draw the FBD of mass m0. So this is mass m0, and as there is no friction between the surfaces, so we will not have the forces corresponding to the friction. So we will have the tension force, let us say T1 force is acting here, so we will have the T1 force, and the acceleration of mass m0 is a0, so we can write T1 is equal to m0 into a0. This is our first expression. Okay, now let us draw the FBD of mass m1. So this is mass m1. Force m1g is acting in the downward direction, and we will have the tension force of T, let us say in this particular thread. So we will have the tension force of T, and the mass is moving in the downward direction with the acceleration of a0 minus w. So we can write the equation here, that is m1g minus T is equal to m1 times a0 minus w. This is our second equation. Okay, let us draw the free body diagram of mass m2. So this is mass m2. We will have the gravitational force m2g in the downward direction and the same tension force of T in the upward direction, and mass m2 is moving in the downward direction with the acceleration of a0 plus w. So we can write the equation, that is m2g minus T is equal to m2 times a0 plus w. So this is our third expression. Now here we are having the variables that we don't know, that is a0, t1, t and then w. So we are having the four variables, but we are only having three equations. So if we draw the free body diagram of pulley, so let us say this is pulley, and we are having the tension force of T1 in the upward direction and tension force of T and T in the downward direction, and the mass of pulley is said to be negligible. So if we write the equation associated with it, so we can write 2t minus t1 is equal to mass of pulley into the acceleration of pulley, and we know the mass of pulley is 0, so from here we can write t1 is equal to 2t. Okay, so this will be our fourth expression. Now let us substitute the value of t1 in the first expression. So from here we can write 2t is equal to m naught times a naught, and from here we can write a naught is equal to 2t upon m naught. So let us substitute the value of a naught in the second and third equation. So finally we can write m1g minus t is equal to m1 times a naught is 2t upon m naught, so 2t upon m naught minus w, and this is our fifth equation, and the third equation will become m2g minus t is equal to m2 times 2t by m naught plus w. So this is our sixth equation, let's say. Now from this particular equation we have to obtain w, that is the acceleration with respect to pulley, and the tension force of T. So further we can write m1g minus T is equal to, so this equation we are writing 2 times m1 by m naught into T minus m1 times w, and here we will get m2g minus t is equal to 2 m2 by m naught times t plus m2 times w. So this is our sixth equation. So from here we can obtain tension force is equal to m1 times g plus w whole divided by 1 plus 2 m1 upon m naught, and from here we can write tension force is equal to m2 times g minus w whole divided by 1 plus 2 m2 upon m naught. Let us equate these two tension, so we can get m1 times g plus w whole divided by 1 plus 2 m1 by m naught is equal to m2 times g minus w whole divided by 1 plus 2 m2 by m naught. Okay, so let us simplify this. M naught times m1 into g plus w whole divided by m naught plus 2 m1 is equal to m naught into m2 times g minus w whole divided by m naught plus 2 m2. Okay, so this m naught will get cancelled. If we take this m naught plus 2 m2 to this side and m naught plus 2 m1 to this side, then we will get m1 times m naught plus 2 m2 times g plus w, that is equal to m2 times m naught plus 2 m1 times g minus w. So from here we can get m1 m2 g plus 2 m1 m2 g plus m1 m naught w plus 2 m1 m naught w, that is equal to m naught m2 g plus 2 m1 m2 g minus m naught m2 w minus 2 m1 m2 w. So this 2 m1 m2 g and 2 m1 m2 g will get cancelled, and finally we can get the expression of w, that we can write it as m naught times m1 minus m2 into g whole divided by, we have m1 m naught minus m naught m2 plus 2 m1 m2 minus 2 times m1 m2, that is equal to w. Sorry, this would be minus and this will be minus. So this is the expression for w, so we can further simplify it m naught times m2 minus m1 times g whole divided by, this would be 4 m1 m2, and this would be plus m naught times m1 plus m2. So this is the expression of w we got, and corresponding to that we can find the t, that is t is equal to m2 times g minus w whole divided by 1 plus 2m2 by m naught. Let us substitute the value of w here, so we can write m2 times g minus m naught m2 minus m1 into g whole divided by 4 m1 m2 plus m naught m1 plus m2 whole divided by 1 plus 2 times m2 by m naught. Okay, so we can simplify here m2 times m naught times 4 m1 m2 plus m naught m1 plus m naught m2 minus m naught m2 plus m naught m1 whole times g whole divided by 4 m1 m2 plus m naught times m1 plus m2 whole times we have m naught plus 2m2. So here we can see these two will get cancel, and finally we can get m2 times m naught 4 m1 m2 plus m naught 2 m naught m1 whole divided by 4 m1 m2 plus m naught m1 plus m2 whole times m naught plus 2 m1. We can further simplify here. We can take 2 m1 common from this particular expression, so we can get m2 times m naught and 2 times m1 into 2 times m2 plus m naught whole divided by m naught plus 2 m1. So we can write here 4 m1 m2 plus m naught times m1 plus m2. So this m naught plus 2 m2 and m naught plus 2 m2 will get cancelled, and finally we will get 2 m naught m1 m2 whole divided by 4 m1 m2 plus m naught times m1 plus m2. Okay, so this is the expression of t we got. Now we need to obtain the acceleration of mass m1, that we know, that is nothing but a naught minus w. So we can write acceleration of mass m1 is equal to a naught minus w. So that is equal to a naught that we have obtained here, that is equal to 2t upon m naught. So we can write here 2t upon m naught minus w, and the value of tension we have obtained here, so we can write 4 times m naught m1 m2 whole divided by m naught times 4 m1 m2 plus m naught times m1 plus m2 plus minus, and the expression of w, that is m naught times m2 minus m1. So minus m naught times m2 minus m1 into g whole divided by 4 times m1 m2 plus m naught times m1 plus m2. I think I missed g here, so this will be g here, g here and g here. Okay, so g will be here. So finally m naught will get cancelled, and we can write 4 m1 m2 minus m naught times m2 minus m1 whole times g whole divided by 4 m1 m2 plus m naught times m1 plus m2. So this is the expression of mass acceleration of mass m1. Okay, so I hope the entire procedure is clear. Thank you.